Hello everybody. Here's an example that I'm looking forward to showing you. Before I do it, I would say that our calculus class is intended for STEM majors, science, engineering majors, people in technical fields, and so on. And so most of the applications I give, I have that in mind. This one is a little bit of an exception, but it's still an example that I like, and I think it's easy to understand, and it's easy to see the application. Okay. And I thought of it one time when I was making the syllabus for the class. So it goes like this. It says that in a class there's only quizzes and tests, two components to the grade. Quiz average is 20%, test average is 80%. And let's say we know the first three test scores. There's one more test to take, all right? And we know the quiz average, all right? So G, the variable G, is the final grade in the class. Calculate dg over dt. Okay? Oh, capital T, that variable is the fourth and last test not yet taken. Okay, so I tell you all that. It reads like a syllabus, like somebody's got their grades and they want to see how things are going to work out. What is the derivative dg dt? Okay, so here's how I put that information together. First of all, this is a derivative. That notation is called Leibniz notation. And in order to find that derivative, we need g to be a function of t. So I need some formula that puts the final grade in the class as a function of the last test grade. In other words, I need some function that if I knew the last test grade, this function would automatically calculate the final grade in the class. Okay, that's what that function is. If you got that function, you can use the rules that you know for derivatives to calculate this derivative. So that would be my first objective in if I need to calculate this derivative. All right. So let's do this. It is possible from reading the syllabus to put a formula together that would do that. It says quizzes are 20%, tests are 80% by average. So if I take 20%, 0.2 times the quiz average and 0.8 times the test average, that will do it. It says the quiz average is 90. The test average I don't know, and in addition to that, I don't know one of the scores. But this is how you do it. I have three tests that are known, 80, 70, 95, and I've got this fourth test not known, designated by the variable capital T. Add those together, divide by 4, multiply by 0.8. That's how it would be done. So right here, it will simplify this, but even if we don't, this formula would do the job of that function. Okay, it is that function. All that we would do from here is simplify it, reduce it, combine some of the numbers, and so on. But this would do it. You plug in T, you plug in the score on that last test into this formula, do the math, and you get the final grade in the class. That's what I was looking for. So the simplifying that I'll do is going to go like this. 0.2 times 90, 18. I'll add 80, 70, 95, that's 245, and I'll split this fraction up in order to isolate the variable. Because if I'm going to use the rules of derivatives, then it would be easiest to apply them if I had this variable isolated, rather than mixed in with all this. So I do like that, split the fraction up, then I'll distribute the 0.8 like that. I'll combine this number 18 plus 0.8 times 245 over 4. That turns out to be 67. That's just a number, just a constant, just lump it all together. And then for this, I'll combine the 0.8 and divide by 4 and get a coefficient on the variable t. That's going to be 0.2. So then that reduces to 67 plus 0.2t. Now this is the reduced form of that function, where again, if I wanted to know the final grade in the class, I would just plug in the grade on that last test right here, multiply by 0.2 and add 67. Now, because I have that, I can calculate this derivative. I just use the rules for derivatives as they would apply to that. What's the derivative of 67 plus 0.2 times t? Well, that's a pretty easy function to work with in terms of derivatives. The derivative of that is 0.2. Okay, so there's your answer. dg over dt is 0.2. Now here's what I like about this question. One, I think everybody should know how to calculate their grade, so we get exposure to that. And two, Like, think about what this means. So the derivative is 0.2. What does that tell you? Okay. Well, derivatives in Leibniz notation have a correspondence to average rates of change. So in general, for say some function where y is a function of x, the derivative dy over dx will be approximately equal to delta y over delta x if delta x is small. So that means the derivative tells me approximately how x and y are going to change together. Okay? Now, if the function that you had is a linear function, like this one is, then dy over dx, the derivative, is equal to delta y over delta x. Okay, so in other words, this derivative is equal to the change in y over the change in x. With my variables, it's equal to the change in the final grade in the class over the change in the last test score. And we can interpret that like this. Now, I think the interpreting is real important because calculus is a mathematical tool. You use it for some problems, but not every problem. In order to begin to learn when calculus is the right tool for the situation, we have to know what everything means. We have to understand what it really is. So this derivative, here's what it is. First, I'll change 0.2 to 1/5, make it look like a fraction. And remember, this is like the change in the final grade over the change in the score in the last test. So I can interpret that 1 over 5 as a 5-point increase in the grade for test 4 will produce a 1-point increase in the final grade. So for every 5 points better you do on test 4, you do 1 point better in the class. All right, that's what it tells you. So I like to, if I find the derivative, I like to know what it means. I like to know how to give an interpretation that in terms of how the variables cause change in each other. Every 5 points better you do on test 4 causes your final grade to go up by 1 point. All right. So there you go. I think that's real important. Now, as a disclaimer, I guess this gives away another way we could do this problem. Do you have to find this function in order to find the derivative? I guess you don't if you know that interpretation. Like, what if I just did the math on some grades and I figured out, oh, for every 5 points better I do on test 4, I do 1 point better in the class. Then you'd know the derivative without knowing this function, without reducing it to that. Okay? But I did it this way in order to show you that we can work with this formula and get a simplified function. And then when we learned all those rules of derivatives, we learned how those rules apply to the derivative that we're looking for here.